Alrighty, my name's Hunter Gideon, and I'm going over the emerging pathogen Microsporidia. As a little introduction, Microsporidia are from the domain Eukarya and the kingdom fungi. These organisms are generalists most of the time. They can be specific to certain organisms. There are thousands of subspecies, the most common of which would be Interocidozoan biennusi. Sorry, I can't say it very well. And these Microsporidia, especially this one, is known to cause microsporidiosis, according to the CDC. Some of the symptoms that can present are rash, diarrhea, CNS damage, and also ocular damage, such as blindness and blurred vision. The transmission is typically through wind, water, and waste, and also specifically in public pools, because they have an inability to live in kind of harsh environments where that chlorine is. Alrighty, so a little bit of a history. The phylum Microspore was discovered in the 1800s. However, they lived for millions of years prior. And the first case that was recognized by medicine was in Japan in 1959. It was a Japanese child who presented to the ER with some bowel discomfort, and whenever they did some tests, they found the microspores. When they initially thought it would be a bacterial infection, it ended up being an intestinal tract infection of Microsporidia. From there, it was starting to present themselves in HIV and AIDS, so immune-compromised patients were more susceptible, and then some connections were drawn between HIV and microsporidiosis. And then between 1993 and 2006, there were dozens of cases that were studied, and they're starting to pop up here and there. And it was really just more people were realizing that it wasn't bacteria, it was caused by microspores. And the treatment for the, microsporidiosis is pretty simple. It's just some basic antiparasitic drugs, nothing specific to microsporidia. So the first area of impact that I'm going to be talking about will be environment. So there are over 1,500 species of Microsporidia that can infect humans and animals. Most of the animals that are affected are going to be animals that live in farmland, such as cows and pigs. So the environments that are most affected are going to be farmland and agriculture. As animals defecate, they can spread the microspores into the crops, and then whichever organisms eat the crops, they would be infected as well. And that's kind of how the transmission works there. And then in a kind of weird way, the HIV and AIDS community as an environment were most affected as a group, because it can be lethal in the HIV and AIDS community whenever the brain is affected. They develop severe symptoms, far more severe than the average person, so it can be much more deadly. Area of impact medicine, the life cycle, kind of a brief overview. The germination of Microsporidia starts with the use of a polar tubule, and that injects sporoplasm into a host cell, and over time that sporoplasm will mature, and then it will bust out of the cell, thus killing the cell and infecting more host cells. In a couple of autopsies, it was found by Anane and Atucci, two African scientists. They found patients with HIV had hepatic damage and also GI tract damage due to Microsporidia, and that was in two separate autopsies. So they started seeing these Microsporidia in live HIV patients. So the treatments to this is going to be just antiparasitic pill, albendazole, and antimicroorganism pill, fumagillin. They aren't really specific to Microsporidia, but they're kind of a general antiparasitic and antimicroorganism pill. So it's just, the CDC also says to keep an eye on this pathogen because it's very likely to mutate and also change into something that's more deadly. So for society, the silent effect, of society was mostly on the HIV and AIDS community. It was the major group affected, especially through the severe side effects such as nephrosis, pneumonia, and encephalitis. The HIV and AIDS community was mostly affected because no one really knew what was going on with these symptoms, and it was just another way that the HIV and AIDS community had to kind of realize the battles they were going through, not only through like discrimination and stereotypes, but also through the Microsporidia. And in kind of a future societal effect, it could be possibly used as a bioweapon, since it's so easily transmissible, and the modes in which they're transmitted are so easily accessible. If it was genetically modified to be more deadly, it could cause some serious damage. So the last area effect would be evolution, and that's more of an effect on itself, millions of years old, like I said earlier, and that's allowed it to go through millions of mutations, and it's branched from the original taxa multiple times, which has led to generalist versus specific separations. The genome of Microsporidia is only 75 to 82 base pairs long, which is like incredibly short. But that also allows it to mutate very easily and also very rapidly. And like I said, that goes towards the generalist versus specific. So the generalists have a lot of versatility, while the specific develop specific attributes to target specific organisms. And some of these adaptations can include chlorine immunity, and that allows them to be in public pools and be a great incubation site there. And also other harsh environments like acidity and extreme heat, and that can allow them to live within an organism, or specifically in the stomach and the GI tract. And they also develop specificity to host weaknesses. With the HIV and AIDS community, the adaptations of Microsporidia could have included something along the lines of targeting the weakened immune cells and infecting through there. And that's also how a bioweapon could be created if they were properly edited and made more deadly. Then the adaptations would subsequently become worse, and that would farther infect and farther kill multiple people. And these are my works cited. I really appreciate you for watching today. Thank you so much. Have a good one.